All right, let's jump right into this explainer and unpack a truly fascinating new report from the Kiel Institute. This research completely flips the script on how we understand global choke points. When we normally think about international conflicts, we tend to focus on the immediate, really obvious impacts. But today, we're going to map out an invisible chain reaction that starts with a sudden military escalation and literally ends on the dinner tables of the world's most vulnerable populations.
To really wrap our heads around the scale of this vulnerability, we just need to focus on one specific number: 21. The Strait of Hormuz is this tiny stretch of water sitting between Oman and Iran, and at its narrowest point, it's just 21 nautical miles wide. Yet a staggering 21% of all global petroleum consumption, plus roughly 25% of the world's liquefied natural gas, passes right through those waters every single day. I mean, it is the absolute definition of a geographic choke point.
And that brings us to a massive question. It's one that military strategists and economists have been debating for decades. If this tiny, absolutely critical bottleneck were to just completely shut down, what exactly happens to the global economy? What's the true hidden cost of a closed Strait of Hormuz?
Well, to figure that out, researchers built a model for a hypothetical, but honestly, entirely plausible scenario set in March 2026. In their model, a military escalation involving the US, Israel, and Iran totally halts all commercial transit. The daily tanker passages crash from an average of about 40 ships a day down to basically zero in a matter of days. It's like a sudden, total cardiac arrest for a major artery of global trade.
Now, I know what you're thinking. Everyone instantly expects a massive oil price spike, right? And for sure, that's the headline we'd see on every single news channel. But here's the thing. That oil shock is really just the tip of the iceberg. The researchers found that standard economic models completely underestimate the disaster lurking just beneath the surface, mostly because they get entirely fixated on the obvious energy disruption.
If you actually peel back that layer of crude oil, you uncover about $773 billion in highly specific global trade that completely depends on the Gulf states. The world relies on this region for over 70% of its hydrocarbon derivatives, nearly a quarter of its aluminum alloys, and get this, even the rare neon gas that is absolutely crucial for making the microchips in our phones and laptops. These are critical ingredients powering global manufacturing, and you just cannot source them somewhere else overnight.
So the really crucial point here is that normal economic models basically assume supply chains are super flexible. If one supplier goes offline, the model just assumes a buyer will easily pivot and find another. But they completely miss what the researchers call the bottleneck mechanism. This is exactly what happens when key, essential inputs simply cannot be substituted in the short run.
Okay, let's look at the actual domino effect that these standard models miss step by step. First, you've got the energy disruption, the physical blockade itself. Second, that disruption creates a massive chemical bottleneck, simply because so many modern chemicals absolutely require that trapped natural gas. And finally, step 3, that chemical shortage transmits directly into soaring global food prices. You can see this cascade so clearly in the data. It brilliantly illustrates how an initial shock in energy costs acts as a trigger, supercharging the prices for chemicals right downstream. And then, if you track that impact all the way down, it slams right into food products, stuff like wheat, cereals, and vegetables. An energy crisis in the Middle East literally, mathematically, translates into a spike in the cost of growing vegetables worldwide.
To understand why this specific chain reaction happens, we've got to talk about the Haber-Bosch process. This is the chemical process that turns methane gas into ammonia, and it is the absolute foundation for almost all of the world's nitrogen fertilizers. You literally cannot manufacture the fertilizer that feeds billions of people without cheap natural gas, and the Gulf states are massive, massive suppliers of it. Put simply, no gas means no fertilizer.
And here is where the timing makes this modeled March scenario so incredibly devastating: the agricultural calendar. March and April are the absolute peak demand months for the Northern Hemisphere's spring planting season. Farmers need that nitrogen fertilizer right then and there. It can't just arrive 3 months late. A delayed application during spring planting means severely reduced yields or even completely failed harvests, which would plunge us straight into a global food emergency.
When you look at who actually takes the biggest hit in economic welfare, it's incredibly telling. This isn't an American or European catastrophe, not at all. It's a severe food security crisis for the developing world, specifically hitting nations that are entirely reliant on importing both their energy and their agricultural inputs.
Just look at this intense disparity. In a full closure scenario, the United States experiences a tiny, negligible 0.07% drop in welfare. It basically barely registers as a blip on the American economy. But meanwhile, a country like Zambia faces a devastating 5.49% drop. We are talking about economic damages in the developing world that are 10, even 20 times larger than anything the West would experience.
At the very top of this vulnerability list, you find countries like Zambia, Sri Lanka, the Democratic Republic of Congo, Taiwan, and Guinea. These nations suffer from what we can basically call a double vulnerability. They simultaneously depend on imported energy just to run their countries and imported fertilizers to actually feed their people. It's a brutal combination.
Okay, to really grasp the economic mechanics at play here, we have to split this into two separate timeframes. On one side, you have the short-run panic. This is a period of intense rigidity, where oil refineries are locked into specific grades of crude, shipping routes are totally severed, and fertilizer buyers are stuck with rigid annual contracts and absolutely zero immediate alternatives. On the flip side, you've got the long-run adjustment, where global supply chains do eventually manage to reroute, substitute, and kind of find a new normal.
But when you compare that initial short-run panic directly against the long-run adjustment, it reveals a pretty harsh reality. Even though markets do eventually adapt and partially recover in the long run, the deep structural damage inflicted during those first few months of pure panic destroys real income. For poorer nations with really thin financial buffers, that is lost wealth and lost food security that they are simply never going to get back.
So what do we actually do about this? Well, the ultimate takeaway from the Kiel Institute researchers is that international institutions need to radically update their crisis playbooks. They argue that we must start treating agricultural chemicals exactly the same way we treat oil. Just like nations hold strategic petroleum reserves, we desperately need to establish strategic fertilizer reserves to stop these choke point closures from triggering catastrophic global famines.
Which leaves us with one final, pretty urgent question to chew on. As the whole world stockpiles fuel and preps military assets for the next big geopolitical conflict, are we completely ignoring the invisible chemical supply chains that literally put food on our tables? It is a really stark reminder that in our hyper-connected world, an energy crisis is always, at the end of the day, a human crisis. Thanks so much for joining me on this explainer, and I'll catch you in the next one.